Welcome to the midterm review session for Operations Management 726 at the Questrom School of Business. I'm Professor Nita Tucker and we are doing problem number 4. As you can see by problem number 4, this is an advanced problem where there's a decision point at the beginning of the process. If you look at it here, this diamond shape means that there's a decision, and the decision is whether the customer decides to customize the product via option A, which is going through this upper part, which would be task A and task B, or if they chose option B, in which case if they did, it would be task C that would get performed, and that would take 8 minutes per unit. After the customization, either one, the top or the bottom, option A, option B, it then moves on to step D, where worker number 3 performs a task for 4 minutes. Now, as you can tell by the dotted green box around A, B, and D, all of these activities are performed by a single worker. However, we have 2 workers that do this customization step. So this is a different problem. The way that this would be, there's a choice and 40% of customers choose option A, in which case task A and task B are done. The remaining 60% choose option B, in which case task C gets done. Something like this. And all of those things are done by a worker. Usually what happens is once a worker is working on something, a particular choice, either A or B, finishes it, so it's not that they split it between the 2 of them, but they're both working at the same time. So the question as always is, what is the bottleneck of this process? So we think about customization as a resource, so let's figure out what is the capacity of customization. So customization 40% of the time, 0.4, takes a total of 11 minutes. Well, 60% of the time, it takes a total of 8 minutes. So we're going to find a weighted average of those 2 options in order to get the task time. And so that turns out to be 9.2 minutes per unit is the average time. But we have 2 workers that are doing this. So we get every 9.2 minutes, we actually get 2 units that come out. So then the cycle time, so this is the cycle time for that step for customization. So cycle time for the customization step is equal to, on average, 4.6 minutes. So we would compare this 4.6 minutes for customization with the 4 minutes that it takes worker number 3. And consequently, then the bottleneck is the customization step. So bottleneck equals customization. And the cycle time for the process is, as we said, 4.6 minutes. We know that taking the inverse of the cycle time, 1 over the cycle time, is what gives us the process capacity. And so we can make 1 unit every 4.6 minutes. We convert this again to hours by multiplying by 60. And then this gives us a process capacity of 13 units per hour. We also want to know what is the average utilization of these 3 workers. So what is the utilization of the 3 workers? And so we have 2 workers at the customization step, and they are 100% utilized because they're the bottleneck. And as I explained earlier, we're assuming for all of these review problems that the flow rate is determined by the process capacity because we have infinite demand for our products. In other words, we're only constrained by capacity, not by demand, and therefore these bottleneck steps are going to be working 100% of the time. So worker 1 and worker 2 are 100% utilized, and worker 3, well, how much is worker 3 utilized? Worker 3 can make 1 unit every 4 minutes times 60 minutes per hour. So this turns out to be 15 units per hour. That's the capacity of worker number 3, but we're only using 13 units per hour. So we can do 13 divided by 15 to get the utilization for worker number 3, and we're going to take the average of this, so divide by 3. And if we do that math, that turns out to be 95.6% utilization. Thank you very much. This was problem number 4 from the midterm review.